Let's talk about scientific notation. In order for a number to be written in scientific notation, it has to be in the form a times 10 to the nth power, where a is a number greater than or equal to 1 and less than or equal to 9. That means basically you want one non-zero digit in front of the decimal point. And n, which is this exponent right here, is going to be an integer, which is basically just a positive or negative whole number or zero. Let's take a look at the examples that you see on your screen. Let's take a number like 4,596. Right now, you don't see a decimal point at all. When you don't see a decimal point, the decimal point exists at the very end of the number. According to the rule for scientific notation, there can only be one non-zero digit in front of the decimal point. Right now, in front of this decimal point, we have 1, 2, 3, 4 different numbers. So that means that we're going to have to move the decimal point to the left. So we are going to move it over 1, 2, 3 times so that we are left with 4.596. And because I moved the decimal point over to the left, I made this number smaller, so I had to balance it out. So I'm going to multiply it by 10 to the third power, which is 10 times 10 times 10, to go ahead and make it bigger again. So 4,596 is equal to 4.596 times 10 to the third power. Let's take a look at the second example. In this case, we have the number 0.000045. Notice this is not written in scientific notation because I have one number in front of the decimal point, but that number is a 0, and it has to be a non-zero digit, just one non-zero digit. Unlike the top problem, I now need to move my decimal point to the right-hand side. So I'm going to move to the right 1, 2, 3, 4, 5 times. So this number, which was tiny, 0.000045 is a tiny, tiny number, is now going to become 4.5 times 10 to the negative 5 power, because I had to move the decimal point over 1, 2, 3, 4, 5 times. And the whole thing about scientific notation is the idea of balancing the number. It used to be tiny, so I had to make it 4.5 times 10 to the negative 5th, because if you make it times 10 to the positive 5, that basically is going to make this into a huge number. Let's take a look at some examples. In question number 1, we have the number 7,600. So here, there's no decimal point. When there is no decimal point, it exists all the way at the end of the number. I have now 4 numbers in front of the decimal point. I'm only supposed to have one non-zero digit. So I'm going to move my decimal point to the left 1, 2, 3 times. So this answer is 7.6 times 10 to the third power. Let's take a look at number 2, 58.13. Right now, I have 2 numbers in front of the decimal point. I'm only supposed to have 1. So I'm going to move the decimal point to the left 1 time. So that becomes 5.813 times 10 to the 1 power. In number 3, I have the number 128.9. I need to move the decimal point to the left 2 times. So this becomes 1.289 times 10 to the second power. In question number 4, we have the number 0.00345. So we need to move the decimal point so that it is after the 3. So that means I have to move it to the right 1, 2, 3 times. So this is equal to 3.45 times 10 to the negative third power. In question number 5, we have the number 0.25 times 10 to the negative 4. So right now I have a 0 in front of my decimal point, but remember, you cannot have a 0 in front of the decimal point. you're supposed to have only one non-digit zero in front, which means you have to take the decimal point and move it after the 2. So this is going to become 2.5 times 10 to the, this is where you have to stop and think. The number used to be 0.25. The number has now become 2.5. The number has basically now become larger. So we have to balance it out by making the power smaller. Since the number basically kind of got larger, that power has to be smaller. So smaller than -4 by 1. And the reason why it's by 1 is because I only moved the decimal point over one time. So smaller, -4 by 1 would make it -5. Remember that in a negative number, the bigger that negative number, the smaller it actually is. So here, 0.25 times 10 to the -4 becomes 2.5 times 10 to the -5. 0.25 compared to 2.5, that number got larger, so therefore I have to balance it out by making the power smaller. In question number 6, the number is 100.25 times 10 to the third. I have 3 digits right now in front of the decimal point. I'm only supposed to have one non-zero digit. That means I have to move the decimal point back 2 spaces. So this is going to become 1.0025 times 10 to the, and then notice what happened. The number used to be 100.25. That number has now become 1.0025. That's a huge difference. It's gone smaller. And because it's gotten smaller, then we have to balance it out by making the power larger. Okay? So in comparison, 100.25 is now 1.0025. And that means the number has gone smaller. We have to balance it out by making the power bigger. And we're going to make the power bigger by 2 because I moved the decimal point back 2 spaces. So instead of a 3, it has to be bigger by 2. So this becomes times 10 to the 5th power. The beauty about these problems is that if you were to put them in a calculator, you can check to see whether you got them correct or not, because whether you write it in the calculator the way the original problem is or your final answer, you should get exactly the same answer. I hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.